Running code from the internet. Please welcome Zbyszek to the stage.
Okay. Yeah, so we're hacking, so I should be wearing my hoodie the right way, like a hacker, right? Is that correct? Okay, I'm running code from the internet, and so do you. Sorry, getting ahead of myself. So, who am I? I've been dealing with JavaScript for a while. I've been organizing and speaking at Meet.js for 13 years or so. And I'm working on a project called LavaMode. That's the next logo. And that project is sponsored by MetaMask, the crypto wallet. I barely know anything about crypto, but I do know some things about JavaScript security, and they find it necessary, you know. And this is my website URL. You can go there, and I'll tell you why in a moment. But first, there's this survey I tend to do. Okay, this is too silly. There's this survey I tend to do where I ask, would you accept a string of text? Like just any string of text. And I promise you it's JavaScript. Would you put it in your application in production and just run it with your customers without reading what I gave you? Would you do that? Okay. That's good results. So would it help if I offered to put it in a tar.gz file before giving it to you? No. I thought so, because that's what NPM packages are. And don't get me wrong, they're glorious. I love them. But they're also unsanitized input from people in the internet that you put in your applications and run, aren't they? Okay, so what we're doing on a daily basis is like consuming all of those packages, and I do that all the time, and you do that all the time. But what if some of them are not actually that great? And I don't mean lousy packages. I published a bunch of lousy packages and nothing happened. But what if they're actually malicious? What if they want to do bad things to your application or your users, right? How would we even know? Well, I'm assuming we just wouldn't, but let's not get ahead of ourselves. So this is a topic of supply chain security, and I've been dealing with that for a while. So it started with me noticing those dependencies, they could be vulnerable. That was in like 2015 or something. And you know, there were some projects like before NPM audit, but mostly NPM audit, that help with that. I started working on getting my team to adopt it. There's a big story about it. I produced this package and gave a bunch of talks about it. Then I looked at malicious install scripts with some fun side effects. Then I moved on to Hardened JavaScript and LavaMode. We're going to get there. But there's also a bunch of talks about it on my website. And then defensive coding and prototype pollution, that was also fun. You should check it out. I run workshops on DEF CON and NodeConf.eu about that thing. They were not recorded, but you can find them on my GitHub, and they are almost self-explanatory. Feel free to get in touch. Okay, and then I went to some events to show running malware live on my machine, malware straight from NPM. I might be able to squeeze that in today. So all of that available at Nagtor.pl. Let's get back to the main topic. Okay, so I'm going to talk to you about what could happen around your dependencies if they turn malicious. Okay, so it's going to be a story. Let's meet our protagonist. That's a random developer. And he decides to install some dependencies. But unbeknownst to him, there's a hacker lurking, offering a package somewhere in the dependencies. Like, you won't even notice, but there's a bad package somewhere in there, okay? So the developer thinks, now I'm not running that. I only execute code from the packages I know, right? Wrong. There's post-install scripts. So whatever is in the post-install scripts, it's going to run when you install the package. Even if you don't use that package, even if you're not aware of that package, it's buried somewhere in your dev dependencies, it's going to run the post-install script as you, the user, running npm install. Okay, so that's how the hacker gets in. All right, so wait, if I do npm install in a Docker container, and then just copy the node modules folder away and destroy the container. Ha, solution, right? Wrong. Okay, so this is a throwback to one of the talks I gave. If you want to see the demo, find the recording. I'm going to walk you through what happened. So I created a package. It was Christmas at my in-laws. I had some evenings to consume. I created a package that would run a post-install script that finds TypeScript next to it in node modules and then modifies the compiled JS of TypeScript compiler to add malicious code to the application it's building. That was fun. And it worked. So, okay, you can turn off all the scripts, right? But then some of those scripts are there for a reason. Some of your dependencies need to build something. What do we do then? We do npm rebuild and name of the package, like bcrypt. Bcrypt needs to compile itself. All right? So, did you know there can be more than one package called bcrypt in your dependencies, and this is not about versions. So, our lovely hacker decides to put a bundled dependency in the malicious package. So, the malicious package can be named whatever, but the bundled dependency that ships inside of the tar.gz file is named bcrypt. So now, when we run npm rebuild bcrypt, we're going to rebuild both. Fun. Yeah. Okay, what now? So yeah, that's when our protagonist finds LavaMode. And that's why I'm telling you the story. Okay, so the first, the entry to using LavaMode is allow scripts. It's a tiny little tool that once you set it up, you're in control of which packages are allowed to run their post-install scripts. Okay, if you want to follow or click any of the links, it's already on my website, by the way. You can just click into it. Yeah, so when you run the tool, in your package.json, there's a section where you can decide which of the scripts should actually run. They're all off by default, and they're identified in a way that you will not get confused by a package of the same name that's not actually the same package. Okay, for added convenience, you can now run any sort of npm install, and after that, run allow scripts to get the result you're expecting with only the right scripts running. Okay, everything else is turned off. We generate the configuration for that. Okay, so at that point, your installation process is safe, right? Well, there's more to JavaScript development than installation. So yeah, now our hacker emails someone, like one of the more famous NPM contributors, maybe. Hey, author of this package, I can see you're tired of maintaining it. Can I take over? Can I help? That thing actually happened. Yeah. So then, when the hacker takes over a package that people actually use, the code for that package could suddenly start running this. What's this? When you run your build in your CI, or if you run your tests somewhere, it's going to grab your GitHub token and send it somewhere. Is that good? No? Okay. Would you go and read your NPM modules in your node modules folder? Well, in case you did, okay, this is a bit less readable, but you can still see GitHub token in there. So yeah, let's keep going. This is a tiny bit of screenshot from the actual full version of the original code with full obfuscation. It's now 60 kilobytes, but you're not going to read it. All right, so what now? Well, there's an app for that. Yeah, so LavaMode, the main feature of LavaMode is protection at runtime. If this sounds unbelievable, it is. I wouldn't believe it 2 years ago. but then I joined the team and learned how it's possible. It's crazy. Okay, so first what you do is you generate the policy for your application, and it creates a policy file. I'll explain it in a moment. And then with that policy file, you can decide which package gets to access which globals and which built-ins and which other packages. So you're in control of every powerful API every single dependency of yours could reach. Okay, and then you run it like instead of node build.js, you run LavaMode build.js, and it runs with the protections provided by LavaMode. So if a package all of a sudden starts reading process env and reaching for fetch, these two are going to be undefined because that package didn't use them before, and that's not in your policy. Yeah, so this is a tiny fragment of what the policy file could look like. So when we generate the policy file initially, some code reads your code and generates this, but you get to decide that you're not going to give them the access. And this package, even if we didn't detect it, these are false by default. So this package would not have access to HTTPS import and to the global named process. And this happens within one process, within one thread, within one context in Node.js, and in the browser, by the way. Okay, so now when we run build with the malicious package that already got in, we're going to get one of the two errors. It's going to either say the allow list would not allow evil package to get HTTPS, or it will tell you that someone tried to read env from undefined. Remember process.env? Yeah, process is suddenly undefined, but only for this package, not for a package that you agreed to use the process reference. Okay, how? Yeah, this is not supposed to be happening in JavaScript, but it is. So what's inside? And this is going to be a very brief explanation of what's inside, and like a very top level one. So inside is what we call hardened JavaScript or secure ECMAScript, SES in short. It's a package. You can also use it. But what it gives us is we can put each of your dependencies in a separate compartment. That's what we call the box in which we isolate JavaScript. And we can decide what the global reference for that compartment is going to be. And this is becoming part of the JavaScript language itself, potentially, eventually. So there's some nice people in TC39 working on a proposal to get compartments into JavaScript. There's a bunch of layers that need to happen first. So, you know, module loading, virtualization, and stuff like that. Like, sounds difficult. Well, try reading TC39 proposals. Yeah, this is moving forward. If I'm optimistic, I can tell you it's going to be there in a year, probably longer. Not guaranteed, but doing our best. And what are the ingredients of the solution? So we have compartment. It's a constructor of this box that can accept code, accept the definitions for globals and module loading implementation, and then run the code in that isolation. There's also lockdown, which you can use totally separately. It's going to block all prototype pollution and stuff. And then there's harden that lets you do the same thing that lockdown does to the JavaScript environment, but to your own objects. Okay, so this is one of my favorite slides. Do you know Conway's law? Conway's law says that an organization is going to ship its communication structure as software. And this happened to JavaScript. So there's ECMA that defines the language itself, and then there's W3C and Node.js people. They define the powerful APIs. So the language itself doesn't contain any powerful APIs, and Conway's law says if there's separate organizations, the separation is going to be strong, And it is. So any powerful API is only reachable through scope. If you go reach for a global, that's your fetch. There's no way to make an HTTP request built into JavaScript itself. We can have working JavaScript without network access whatsoever. That's the good separation, and Hardened JavaScript leverages that separation. Okay, that was a lot. So to sum up, we have install time protections with allow scripts. This is something you can roll out to your application in 10 minutes and be 90% safer. We have runtime protections with LavaMode and policy. That's a bit less trivial to introduce, but I'm willing to support you with that. We want feedback. And then we have hardened JavaScript and SES, which you can use directly for your very specific use cases. Okay, so LavaMode is protecting the installation, the build time, and the runtime of the crypto wallet called MetaMask with 30 million users. And that's been going on for like 2 years. So what are you waiting for? Okay. News, there's also a bundler. So for MetaMask, MetaMask was originally bundled by Browserify. So it was the easiest to integrate also. So we have full support for Browserify. I know most of you don't find it interesting. Yeah, I'm gonna skip the history lessons. But we've finally figured out another integration we can do. It's a Webpack plugin, so if you're using Webpack, you can try out our beta. We're looking for reports on what breaks. It's not fully production ready, but do try it out if you dare and see how it works. Speaking of seeing how it works, do I have the time to show you something?
No.
That's too bad.
I'm joking.
How many minutes?
3.
Oh, awesome. Yeah. Okay, so look, this is an app. This app is using an external package called Cookie Monster. Okay? And you get a random quote from a Cookie Monster, and then you get a reaction from a TypeScript implementation. What's the TypeScript? Well, we needed strong typing for this, all right? Yeah, that's TypeScript for you. Okay, I just wanted to prove that bundling works. So I have this setup. This is the old internal code name for our Webpack plugin, by the way. Ignore that. Yeah, this demo is kind of old. This stuff works better now. So I have a Webpack config with just the plugin added. Okay, and here in the browser, yeah, I have 2 versions. This one was bundled without the LavaMode plugin, okay? So if I run the application, I'm getting some diagnostics that are printed out. I'm getting the quote from Cookie Monster and the response from TypeScript. And also, Cookie Monster happens to be implemented like this. Not only does it return the random quote, it also grabs your cookies and sends them to his server. Okay? What did you expect? It's the Cookie Monster. Okay, so we're getting a request here in the network tab that says name equals chocolate chip because this is what we set as our cookies. Not cool. Okay, what happens if we build that with LavaMode plugin? Yeah, so same thing happened, random quote from the Cookie Monster, and then undefined instead of the actual cookie content, okay?
Wow.
Thank you.
Zbyszek, very powerful and energetic presentation, as promised, and with cookies.
With cookies. I said there was going to be cookies.
I'm really, really impressed, and you made me a little bit more, let's say, nervous about the security of everything and how safe we really have to be, or think about, at least attempt to be. You have a question, sir?
Yeah. Have you thought that the script checking and such capabilities of LavaMode could be implemented as a part of NPM or like any other package manager, so it would be possible in package.json? Do you think it's a good idea or not, or it should be kept separate?
It's a very big topic. Thank you for the question. NPM is allergic to breaking changes. So they got the proposal to disable scripts by default. I don't want to lie to you, but like 8 years ago for the first time, maybe. Yeah, that didn't fly. So we're not going to get a breaking change anytime soon. And blocking all scripts is also not a good option. So allow scripts is the simplest way we could find, because we didn't want to write it, we just wanted to be protected. So allow scripts is the simplest option we found to protect against malicious post-install scripts.
Yep, I have it.
Okay.
Sorry. So basically, the LavaMode, is it LavaMode? Yeah.
Yeah.
LavaMode is kind of a glorified polyfill for the proposal.
Well, LavaMode is built on top of a glorified polyfill. So SES is the polyfill.
The question that I had is more of a curiosity. Is anyone from LavaMode, are you involved in the championship of the TC39?
So LavaMode people are building a useful and fairly simple to use interface on top of SES, which is the actual shim that is being presented to TC39 as the example, one of the example implementations of hardened JavaScript. So LavaMode is here to stay. SES is going to be consumed into the language, like 80% of it, 90% of it will go away because it's going to become part of the engine itself eventually.
Okay, here. To use allow scripts, you have to install first, and you have some depths on that. Do you trust them?
We review them, and there's not a lot of them. So yes, you need to you need to start from a position of trust, but we're also working on improving the developer experience. So eventually, we're going to have a tool that lets you install allow scripts before you install anything in your project. So currently, you could try doing that if you globally install allow scripts and then run it locally, like the terminal command, and that's going to work. And so you don't get to accidentally install all of your other dependencies when you're introducing it to the project. But the overall assumption is we're starting from a point where we felt somewhat secure. So we're assuming today everything is secure. We want to protect ourselves from a future package takeover or any sort of maliciousness showing up in the dependencies.
I don't really use Dino, but if I understand it correctly, it has a similar thing to this runtime policies, except it's on a per process level rather than a per dependency. So the question is LavaMode a strict superset of the functionality of Dino's policies, or?
Nope. LavaMode policy is older than Dino, so it had no chance of being inspired by Dino and being a subset. It's a different kind of policy, and we have a bunch of ideas on how to simplify it, etc. So it's going to develop independently, and yeah, it's per compartment, and LavaMode is applying compartments per dependency in your dependency tree. So different granularity than Dino. If we had time, I have like a few slides about that topic, but yeah. I'm not going to do that.
I have a question, because you showed that for each package, I can configure the APIs that it can use to limit its capabilities. So let's say your average JavaScript project has, I don't know, maybe 10,000, maybe 100,000 dependencies. So do I have to specify all of those manually, or do you have some automation for that?
Yeah, that policy generation is the automation you're talking about. So LavaMode protections are based on SES, which is not parsing the JavaScript at all. It's implementing the protections at runtime in the language. But LavaMode has a feature to read all your code and generate the policy, and then you only specify the overrides file. It was somewhere here. Okay. Policy override is where humans put stuff, and policy JSON is the one that's generated. So every time you update your dependencies, you regenerate this file. Look on the diff. If the diff doesn't say child process or something scary like that, it's okay. You can run it. And your overrides are elsewhere. And you can make the policy stricter with your overrides. You can expand it to allow for stuff that we didn't notice is actually needed. Yeah. I think
Zbyszek,
I have to finish.
Thank you very much. No, really. Zbyszek will not be leaving immediately, so give him a big hand.